We're on worksheet 3.1, and this is problem 1. We're going to go through these problems a bit faster than we did for the examples. So for the problems, really what you need to do is just do these on your own and see how well you do. So I'm just going to go through real quick on these ones and do very little work and just get to the answer. So the first one, limit as x approaches 3, x squared minus 9 over x minus 3. So remember that what we want to do when we see something like this is, first of all, notice that if I try to plug in 0, I'm going to get that 0 over 0 problem. So what do I attempt to do? I see that I can factor this. The numerator is actually the difference of squares, so it can factor as the difference of squares. And then you see what happens with that. This x minus 3 terms are just going to cancel. So what are we left with? The limit as x approaches 3 of x plus 3. And at that point, we can simply plug in the 3 and get 6. OK, for part B, we get, actually, B I'll do a little bit more on because we didn't do one like this for an example. So this is the limit as x approaches 0 of 1 over x plus 3 minus 1/3. And this whole thing is then divided by x. So what we want to do on these types of problems where you see kind of fractions divided by fractions, we want to actually just do the subtraction that it says to do there. And that is, in order to subtract these things, we need to have a common denominator. So the common denominator is just the product of these things, 3 times x plus 3. So that means this denominator needs a 3. So I'm going to multiply this by 3 over 3. And that's 3 times 1 there. And then this one needs an x plus 3, so I'll multiply that by x plus 3 over x plus 3. So what does that do? Well, that allows us to add the numerators now, or subtract them. So we'll have a 3 minus, and then this quantity here, 3 minus x plus 3. And then that's divided by the LCD, which was 3 times x plus 3. And then this is still all over x. And we can actually write that as x over 1. And then realize that when you have a fraction over a fraction like that, you can invert and multiply. So let's simplify that numerator. We're going to get 3, sorry, limit as x approaches 0. 3 minus x plus 3, that minus will distribute. The 3's will cancel. I'm going to be left with a minus x over 3 times x plus 3. And then I can invert and multiply that x over 1. And at that point, you can see that these are going to cancel. So what am I left with? Negative 1 over 3 times x plus 3. At that point, I don't have a problem anymore with simply plugging in 0. So I'll do that. If I plug in 0, I'm going to be left with negative 1 over, if I plug a 0 there, 3 plus 3, 3 times 0 plus 3, that's 3 times 3, that's 9. So I'm going to have negative 1/9. OK, for the next one, C, we saw one like this, very similar to this in the examples. The limit as x approaches 36 of root x minus 6 divided by x minus 36. So remember, one of the ways that we could approach this is multiplying by the conjugate. That's what we'll go ahead and do here. We'll multiply by the root x plus 6. We'll do that in both places. And remember what that does in the numerator when you have the multiply by the conjugate. You basically just multiply the first term times the first term, last term times the last, and then see what you have in the denominator compared to what you have in the numerator now. These are just going to cancel. So we're just left with then limit as x approaches 36 of 1 over square root of x plus 6. At which point you can just plug the 36 in. The square root of 36 is 6. So we're going to have 1 over 6 plus 6, so 1 over 12. For part C, for part D, we have a limit at infinity. So remember on these ones, now that we kind of know that trick, we really don't have to do too much work on these. So this is the limit as x approaches negative infinity of 3x squared plus 2x divided by 2x squared minus 2x plus 1. And now, really, if you remember, all we need to do is just check what's the highest power? Second power. What's the highest power in the denominator? Second power. They're the same. What happens when you have the same powers, same highest powers in both places? The limit is simply the ratio of the leading coefficients. So that's all there is to that one. For part E, pretty similar. Now we're talking the limit as x approaches infinity of 2x squared minus 1 over 3x to the fourth plus 2. So again, it's really important that we notice that in these last two, we're going to either infinity or negative infinity. Totally changes how we have to approach the problem. Again, we can compare powers here. Highest power now is in the denominator. Remember what that does. If the highest power is in the denominator, what's the limit? It's 0. And we don't really have to do any work besides that. So there we go for problem 1.